Hi, thanks for joining me on this week's Science at Home activity. I'm Jeff Mucklin with the Nurture Nature Center, and in this week's video, we're going to be talking about astronomy, and then we're going to learn how to make two tools to help us better understand the night sky and objects within our solar system. Now, one of the best ways to observe the night sky is with a telescope. Like this one. One of the most important parts of any telescope is the objective, or the primary lens or primary mirror. This particular telescope here has a lens. You can see it right here. And this gathers light and it brings it to a focus here at the eyepiece. Now, in the world of telescopes, bigger is usually better. The bigger your lens, or the bigger your mirror, this would be a curved mirror. The bigger this is, the more light you can gather, and the sharper the image you can create, the dimmer the object you can see. And particularly for a beginner, for somebody who's trying to learn about the night sky for the first time, being able to see more of the sky at once can be very helpful. You might be looking for a particular constellation, or using some stars to find a particular planet. This is called using guide stars. The more stars you can see, the easier that might be for you. So even a pair of binoculars is a great way to observe the night sky. All you need is a clear night. If you are interested in learning more about astronomy, you're going to need a roadmap, sort of. You're going to need a way to navigate across the sky. And one way to do that is with a planisphere. This is a planisphere. It's a disk that has the night sky printed on it. And there's a little viewing window here and a circle that has all of the 12 months of the year. And there's a time listed around the edge of this. And the way you use a planisphere is you rotate this disk so that a particular time is over a particular date, and that shows you what the night sky would look like at that time and that date. Make your very own star wheel that looks just like this. It's very easy to do. We're going to provide a link in this with this video that will show you where you can download this, but it's just two pieces of paper that you download and cut out. On one piece, you'll print out a circular image of the night sky, and we can see times, different dates, and we can see the months of the year all around the outer edge of our wheel. And the other piece of paper says star wheel. It has a picture of two people looking at the night sky down there in the corner, and it's got the time of day listed around its edge. So you cut out these two pieces of paper, and you get something that then looks like this. You cut out a hole, a viewing window through there. So, and then you just insert this in here. And now, by rotating the star wheel, you can see what the night sky will look like at any given time of the year and at any hour of the day. And so now you have a way to see what you're looking at. What are you looking for? Maybe you're going to look for the planets, right? That's always a fun thing to look at. You can see some of the planets actually without a telescope, by the way. You can't see Uranus or Neptune without a telescope. They're just too far away from the sun. They're too distant. They're very dim. But with the naked eye, even without a telescope, you can see Saturn, you can see Jupiter, Mars, Venus, and even Mercury from time to time, if you know where to look. Now, I don't have a map for you of where you can find these things in the night sky, but I am going to show you how you can make your own map of our solar system. We're going to make a scale model of our solar system. So we'll see the distances, the relative distances between the planets. So if you want to make your own scale model of the solar system, you're going to need a couple materials. You're going to need a strip of paper. I have receipt paper here that I can cut a meter long. Now, you might not have receipt paper like this, but I found that if you just take a piece of office paper and cut it into 4 strips and tape them all together, you can get a strip of paper that's about a meter long. It's actually a little bit longer than a meter. And you're going to use your yellow marker. At one end, you're going to draw a crescent sun. And at the other end, you're going to want to put some dots, little black dots, maybe some potato-shaped objects here and there, lumpy shapes. These dots represent the Kuiper belt, which is sort of the edge of our solar system. So at one end, we've got the sun, and at the other end, we've got the Kuiper belt. Now, the Kuiper belt in real life is about 2.8 billion miles away from the sun, or 30 times the distance from the Earth to the sun. It's incredibly far away. So let's put in our first planet. To do that, what we're going to do is we're going to take our strip of paper and we're going to fold it in half. So bring the sun all the way up to where the Kuiper belt is, and then make a nice crease right here. That point is approximately where you will find the planet Uranus, my planet Uranus. Notice I drew the rings on a tilt. Uranus is tilted relative to the sun. The Earth has a tilt too. The Earth has a 23-degree tilt. Uranus's tilt is over 90 degrees. It's 98 degrees. So now, for our next planet, so fold the paper in half again. Okay, so we've folded it like we did when we were putting on Uranus, but now you want to take this and fold it one more time. So now we've folded it into quarters, and we crease it again. This will produce 2 more lines on our sheet of paper. On the line closer to where the sun is, you're going to want to take an orange marker, draw a line. This is the planet Saturn. Saturn is the second largest planet in our solar system, but it's the least dense. And of course, it's famous for having a large ring system, the biggest, grandest system of rings in the entire solar system. Now, for that second crease that we just put in, you're going to want to get a blue marker and draw a line there. This is the planet Neptune. Neptune is the most distant major body in our solar system. Because it's so far away, it is very, very dim and hard to see. What we're going to do is we're going to take the sun side of our strip of paper, and we're just going to fold just that side up to Saturn. So we've taken our sun and we've brought it up to the line that we put down for Saturn, and we're going to crease it. And the line that we created now, I'm going to use orange again for this line, because this is the planet Jupiter. I'm going to put maybe some brown in it too, though, just for the different weather bands. Jupiter has, even through a moderately sized telescope, you can see these different strips of color, and you can see a red dot on Jupiter as well. That's the Great Red Spot, which is a hurricane, and that hurricane is about as big as the entire Earth. So that gives you a sense of how big Jupiter is. It's a truly enormous planet. So now let's take our sun and fold it up to Jupiter and crease again. The line we've just created will be the asteroid belt. So much like we did for the Kuiper belt, I'm going to put some little black dots. Okay, so now we take our sun and we fold it up to the asteroid belt. And we crease. And on this line, I'm going to use a red marker because this is where the red planet goes, the planet Mars. There are robots on Mars, actually. Right now, as we speak, there are 2 functioning spacecraft, robotic explorers on the surface of Mars sent by NASA, and that's the Curiosity rover and the InSight lander. We're going to take the sun, and we're going to fold it up to Mars, just like we've been doing with the others. And now we're going to fold that again. So we're putting in 2 folds. So we folded up to Mars, and then we folded that strip of paper again. And when we unfurl this, you'll see that we have now added 3 more lines. So using, a brown marker, I'll put a line and a circle for the planet Mercury. Mercury is the smallest planet in the solar system. It's the closest to the sun, and it orbits faster than any other planet. It actually can orbit around the sun in only 88 days. It takes the Earth 365 days to do the same thing. So our next line is a yellow line, and that's going to be the planet Venus, and we draw a circle for that. Venus is the hottest planet in our solar system. The surface temperature on Venus is 950 degrees Fahrenheit. It's also the closest planet to the Earth. And for that final crease that we created, I'm going to use a blue marker again. I'm going to draw a blue line for the Earth. And maybe I'll put some little flecks of green in there to represent the continents. So there we are. We've arrived at Earth, and we've created a scale model of the entire solar system. And I'm going to hold this up close. Look how close together the inner planets of the solar system are. And then look how things stretch out as we go further and further out into the solar system. We have to go halfway to the edge before we reach the planet Uranus. There goes Neptune, and finally the Kuiper Belt. Okay, so thanks for joining me. We just made a map of the stars, and we made a sort of roadmap of our entire solar system. Thanks for joining me. Catch you next time.